Yes.
Okay,
Yep,
fantastic.
all good.
All right, so let's jump on in here. Sorry about the delay, guys. Apparently, Teams just doesn't like me. So there you go. But we're gonna make this happen. All right, so one moment to get my screens organized on my end. Okay, so
There we go.
if you're in this meeting, it's because you are either curious to see if I have any ability to present, or you would like to see what's going on with water. So this is a presentation that I put together specifically with the intent of presenting to people who are curious about water but do not want to get a degree in chemistry. And so that's kind of what we're going to do. So I don't know if there's a way for people to raise their hand in here. So I'm just going to go ahead and ask the question. If anyone, I mean, how many people here do use water adjustments currently? And I'm going to hit view all to see if I can see more people. Okay, I see Steve. Okay, so some of you do, some of you don't. So I'm going to approach this as if everyone on this call has never actually looked at water, but has always been curious, and that's kind of the approach we're going to take. So water is a lot of times in old and in conventional wisdom. If you talk to a brewer, someone's been brewing for more than 10 years, they'll say if it tastes good, it's good. Or they'll say, don't worry about water, so many other things. And so it's often overlooked, but water really is the lifeblood of your beer. It's more than 90% of your beer is water. And it really is something that can have an extreme impact on the taste, the aroma, and the mouthfeel. Oftentimes, it's something that we don't pay a lot of attention to simply because it's presented in many aspects. Like if you read the book Water, it comes across as really hard and complicated. So my goal here is to simplify water and make it accessible for everyone. So in this presentation, we're going to talk about pH and its impact on sugar conversion. We're going to talk a little bit about, actually a lot about sulfate to chloride ratios, give you some ideas on how to identify your current water profile, and then looking at some of the tools available online to do water adjustments. And you guys, unfortunately, will not be getting the tasting the impact. When I do this presentation live, I will have 2 alt beers that have been split into a 2-to-1 sulfate to chloride and a 1-to-2 sulfate to chloride ratio to do a taste impact. But in about 2 months, you will be able to read that on one of our Brewlosophy articles, because it is going to be an experiment, a beer experiment. I can never say it properly. The beer experiment. Okay, you guys get it. All right, so let's start off and talk about pH and what pH is. So pH is basically the measurement of how much acid or how much alkalinity is in that water. And on the right here, you'll see that very, very acidic would be battery acid. And on the other end is sodium hydroxide. 2 things you don't want to touch with your skin, by the way. The farther away we go from water, the more something is uncomfortable to touch. And if you look in the 3 to 6 range, actually 3 to 7 range, that's really where, as brewers, this is where we live. When we are pulling our strike water, we should be looking at somewhere between 7 and 8 for that pH. Your ideal mash, and we'll talk about why it's ideal later, is going to be 5.2 to 5.6. Now, ironically, and we've done some Brewlosophy experiments, you can do a lot of things to drive your pH crazy during mash, and the yeast is almost always going to fix it and put it somewhere between 4 and 4.5, unless you're doing a sour, and that's going to be the 3.5 to 3.8. Before we talk about how pH impacts sugar conversion, this is just a real quick down and dirty look at how starches turn into the sugars that we use. And I'm going to screw these words up, so please don't laugh, especially if you're on my screen right now. Please don't laugh too hard when I try to say some of these words. But you have a starch, and that is basically the the grain in your stripe water. That's going to create your starch. And then we have enzymes that are going to act on that starch and convert it into sugars. We have the alpha amylase and the beta amylase. And the alpha is really when we are mashing at 153 to 162 range. That is going to be our alpha range. And that is what a lot of people will talk about. You get a less convertible wort, and you're going to get more body. The reason is because if you look at the way the alpha amylase enzyme attacks that starch, it doesn't take it from the ends, it just takes it randomly from the middle. And so it ends up with these pieces that are too long to convert properly into our wort, but too short for another enzyme to get in there and eat it again. But if you look at the beta side, it takes them off the end. So it takes one off the end, and it takes another one off the end, and it takes another one off, and it keeps doing that until it eats all the way through that starch, making it where it is going to be able to get a lot of that converted. And that's why when you mash it 144 to 153 Fahrenheit, you are going to have a much more you're gonna be able to get a lot more alcohol and attenuation out of that wort. So you have these two enzymes. They both have different pH levels that they love to live in. Those enzymes will work outside of these pH range, but your alphas are going to work best at 5.3 to 5.7. Your betas are going to work best at 5 to 5.4. That's why when we typically talk about the ideal pH for wort, we're looking at that 5.2 to 5.6, which is going to cover both your alpha amylase and your beta amylase. So hopefully that's the most complicated part of the whole thing, is just understanding the pH, and that takes us to our ideal pH. And the next thing I'm going to tell you is how to, don't worry about all that and just simplify the pH process. So if you want to really, really dig deep into water and pH, I highly recommend John Palmer's book. I read this book, and then I read it again because I didn't understand it the first time I read it. And then I watched his lecture, and then I read it again, and it started to make sense to me. But one of the things I learned when I read this book is 95% of this book is about pH. And the reason is because if you're a commercial brewer, you have to have your pH right, because you have to have an expectation of what conversion you're going to get from that wort every single time. You need consistency, because if you're making a beer that's a commercial beer, it has to be the same every time. So pH is really important. For us home brewers, it doesn't matter as much. You can make good beer at the wrong pH, but you're not going to get as efficient conversions. So you don't have to understand all the chemistry that goes in, because most of the chemistry in this book talks about all the things that all the levers that get pulled on your pH. But we can make pH really easy, and that's what I'm going to do. I'm going to try to take all the pH stuff and simplify it to 3 options. Option 1. Actually, in all these options, you're going to need to get a good pH meter. You'll see these are 3 pH meters I've actually owned. The $40 one corroded in like 3 weeks, so that was a piece of junk. The one that there's the Oakton, that one is good for about 8 months, and then the even when you keep it in solution, the probe went bad on me. So I had 2 of those. I highly recommend the Milwaukee, because if the probe goes bad on you, you unplug it and you get a replacement probe. So whatever you use, you do have to have the ability to know what your pH is. You're going to want to calibrate it every single time. And so if you want to make a real simple way to do your pH, just mash in your grain, take a pH reading, and then if your pH is above 5.6, add a little bit of lactic acid, let it mix. If you're still above 5.6, rinse and repeat. If you are below 5.2, you added too much, make notes, next time don't add that much. That's as complicated as pH has to be. You don't have to understand all the math to get your pH in a place where your enzymes are going to be nice and happy. The second option is you can use software. There's lots of online software tools. Brewfather has one. Brewer's Friend, Beersmith, Brew and Water, and Grainfather all have water tools. And in order to do option B, you're going to need to have your water profile inputted into that software, and then it will tell you how much lactic or phosphoric or citrus acid to add to that mash to get to the numbers you expect to be. And there's a third way. Now, this is something that's new on the market. 5-Star makes a product that they just released called 5.2. And what this does is you add a couple of teaspoons of this into your mash or into your strike water, and it will put your pH in the 5.2 range. The downside is if you want to do additional water adjustments, mineral adjustments, to impact the flavor and profile, the 5.2 option doesn't work. But if you simply want to get that pH to 5.2, there's a product that will do that for you. Before I go on to the next piece, are there any questions? And just unmute yourself and ask questions if there's any questions about what I've already covered.
Would you recommend option C?
So from what I do, again, there's 1,000 ways to brew, and there's none of them are wrong. So I am using water adjustments specifically to impact the sulfate to chloride ratios. And I've done a lot of brewing where I've not even had lactic acid, and I just let the acid be high. You know, when I'm doing my light beers, I was, you know, having like 5.9, 6.0s, and all it means is when I make that particular beer, I don't get as much sugar conversion. So to me, the pH is a nice thing to have, but the part we're going to go into next with the sulfate to chloride ratios is really where I think the value of water adjustments comes in. But with that said, if you want to have consistency, in order to have consistency across light beers, dark beers, and different beers, you have to have happy enzymes, and the happy enzymes are loving that, you know, 5.2 to 5.6. So I hope I answered your question. I wouldn't do it, but I wouldn't say someone else shouldn't do it.
And one thing I would add is that like the calculations are great, but they're no substitute for a pH meter. So if you're going to obsess about pH, which I really don't, I would say like definitely have a good pH meter so you can take those measurements during the mash, just so you know if your calculator is there or not, because there are little variations in there that it can't always account for, like when your water changes.
Exactly. And that's where a good pH meter, I recommend that when you are brewing, you should have you should have a good idea of what your strike water is. You should have a good idea of what your pH is after you add the grain in. It doesn't really change. Now, I have friends on this call who will tell you that you should also be pulling that pH meter out when you're kicking into the fermenter, and also when you're kicking into the keg, and knowing those pH meters. I personally don't have the skill to pull the levers at those other stages, so I just worry about getting a happy wort situation so I can get good conversion. And this is going to take us to our next stage, which is.
One thing I'd add about the I can't talk from personal experience, but the pH2, that's a product that's been out for a long time. And online, I've read a lot of negative things about it. Like, it works for if you're starting with a very specific water profile, it works. And I do believe it adds a lot of sodium as well to the mash. So I don't think it's something based on what I've read, I wouldn't recommend people use it, because I think it doesn't actually do what it says it does, unless you happen to.
I've not used it personally. I was talking to the 5-Star folks over there, and one of the things they said is that it really is for, it does add a lot of calcium. I know it adds a lot of calcium because it has a lot of buffering. And that's why once you put that in, you really don't want to go and start doing other additional like gypsum or calcium chloride, because you will end up with a very minerally beer.
Yeah, Brent, thank you for bringing that up. I agree. 5.2 is a great product if you have neutral water. If you don't have neutral water, which is most of the club in Southern California, 5.2 is likely to give you off flavors you're going to be unhappy with.
Thank you, Nick. Okay, so let's talk about what you should be paying attention to. So we've already gotten pH out of the way. So that water book we were talking about earlier, you just took 90% of that, and now you don't need to read that part. You just go straight to the back of the book where they talk about chloride and your sulfate, your chloride levels, and then some of the other chemicals. So if you're gonna be adjusting your water, you have to have a good idea of which minerals you want to be touching. So calcium, in general, you want your calcium to be between 50 and 150 parts per million. So I'm just going to assume that no one here knows what a part per million is, and just simplify that to it's how many parts there are per million. I don't think I explained that very well, but you guys get the idea. So 50 to 150 parts per million is going to support healthy enzymes and yeast health. With your magnesium, you want that to be 10 to 30. Also, I should say, when your calcium gets high above 150, you are running into the risk of possibly having noticeable minerally. You ever had a beer and it just tasted kind of like it had minerals in it? Usually that's because someone went too heavy on the gypsum and calcium chloride trying to get the ratios, and because they started with a good amount of calcium, they ended up overshooting that number. So that's one number you really want to pay close attention to when you're doing your water adjustments. Magnesium, 10 to 30. It aids in the yeast and enzymes, and at moderate levels, you're going to prevent those off flavors. Sodium, 10 to 50 parts per million. You want to keep that low to avoid off flavors. Your carbonate, bicarbonate ranges based on the mash pH and the beer style. Now the sulfate and the chloride, these are the two workhorses of water adjustments. Sulfate can be as low as 0. It's not going to be noticeable at 50. It's not going to be noticeable anything less than 50, but it could be 0 up to 300. Once you get above 300, you're going to start running into the risk of possibly getting some off flavors. And your chloride is more of a range of 0 to 100. If you have a very hoppy style beer, you're going to want the sulfates at that 150 to 300 range, and your chlorides, your calcium chloride. And when I say chloride, we're really talking about calcium chloride for the most part. And when I say sulfate, we're really talking about gypsum. So again, those are two minerals you should have in your brew house if you want to do water adjustments, because those are the two you're going to be touching most often. You might add a little baking soda sometimes based on the style, but these are the two, when you run the water profiles in the apps, these are the two that it's telling you: gypsum, calcium chloride. So if you want to have a very hoppy beer and you want to accentuate the bitterness and the crispness, you're going to look for a high sulfate to chloride ratio. And if you want a beer that's going to accentuate the maltiness, you're going to want that sulfate to come all the way down to 0 and less than 150, and then run that chloride between 50 and 100. And these are the ratios that you really want to do takeaways as you're looking at these influences. For a hop forward beer, your sulfate to chloride ratio is going to range from a 2 to 1 to a 4 to 1. If you have a 1 to 1, that's really going to emphasize a balanced beer where you're not putting emphasis on the sulfate and you're not putting emphasis on the chloride.